Example 6. When the price is P dollars per widget, the demand for widgets is given by Q equals 100 times 2 to the negative P power. Find a formula for the rate that the revenue change as a function of price. So what ends up happening here is we're looking for a rate of change. So we know we want a derivative and we see a function, but be careful because that is the demand function and we're asked to take the derivative of the revenue. So first we need to find the revenue. Recall that revenue is price times quantity, and we're going to find this as a function of price. So P will be our input. R of P is what we're trying to create. That means we're going to need only P's in this equation we're about to create. We're given a quantity and that's it. So the price is just going to be represented by P. And the quantity, which is usually represented by Q, can actually be swapped out for the 100 times 2 to the negative P power. Don't worry about the negative exponent. You might want to clean this up instead of having the multiply, but really we can't multiply 100 times P, although perhaps we'd write 100P times 2 to the negative P power. So now we're ready to look at the rate of change for the revenue, which for us is the derivative of the function that we just found. Now, as I look at this blue 100P times 2 to the negative P, hopefully it catches your eye that the variable P that we're taking the derivative of shows up twice, and those P's are separated by a product, a multiplication. So we need to use the product rule, which means first we have to identify the F portion, everything before the exponential piece, and the derivative of 100P is just 100. Our G function is the exponential piece, and so when we take a derivative of an exponential, if you remember, we copy the question, take the natural log of the base, and take the derivative of the exponent. And when we go to clean this up, we're multiplying -1 times the natural log of 2. So we may write this negative log of 2 times the exponential piece. So now we're ready to take the derivative R prime. So remember, the formula says start off with F prime, which for us was 100, times the original G, so just the 2 to the negative P power, plus, and then we have the original F function of 100P times the derivative of G, which is the negative natural log of 2 times 2 to the negative P. You can't clean up either term. There's really nothing to multiply. You could rearrange a few terms. So since there's nothing to clean up, and generally we look for factoring anyways first, let's start with the first part of the first term. I see 100 on both sides of the plus sign, so I can factor that out. Moving to the rest of the first term, we're going to factor the 100 out. I see the 2 to the negative P power on both sides of the plus sign, so I can factor a 2 to the negative P out. And at this point, I've exhausted everything in the first term, so there's nothing left to look for factoring. So my derivative will start with the 100 that I factored out times the 2 to the negative P that I factored out, and now I'm ready to see what's left. Because I factored everything out of the first term, remembering that I need a first term to come before the plus sign, that means we need to put a 1 here, so that when I distribute, everything would go back to the left side of the plus sign. To the right of the plus sign, all I'm left with is a P, and that's times negative natural log of 2. So it's really like -1 times natural log of 2. So P times -1 would just be negative P natural log of 2. At this point, it feels like I shouldn't really actually even have the plus sign there since it's followed by a minus sign, but we'll go ahead and just mark this as our answer.